Greetings to all my tech heads out there in the KevTechify Nation. And if you're new here, welcome. In this episode, we're going to look at authorities and the PKI Trust System. We'll be discussing public key management, the public key infrastructure, the PKI Authorities System, the PKI Trust System, interoperability of different PKI vendors, certificate enrollment, authentication, and revocation. And then finally, we're going to look at the certificate authority stores. This episode is part of my series on network security for the Cisco Certified Networking Associate, also known as CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. When establishing an asymmetric connection between two hosts, the host will exchange their public key information, typically known as a PKI. Now, an SSL certificate here is a digital certificate that confirms the identity of a website domain. Now, to implement the SSL on your website, you purchase an SSL certificate for your name or for your domain from an SSL certificate provider. The trusted third party does an in-depth investigation prior to the issuance of these credentials. Now, after this in-depth investigation, the third party issues credentials, the digital certificate here, that are difficult to forge. Now, from that point forward, all individuals who trust the third party simply accept the credentials third party issues. Now, there are some examples here of certificate authorities. Typically, they're called CAs. Here we have Identitrust, DigiCert, Setco, GlobalSign, and GoDaddy. These are all the most common certificate authorities out there. There are also Let's Encrypt. This is a nonprofit certificate authority that offers certificates free of charge, but they have a very short period of time that those certificates are good for. They're free, but they expire quite quick. The public key infrastructure is needed to support large-scale distribution and identification of public encryption keys. Here are the main elements for the public key infrastructure. First, over here, we have the PKI certificate that contains an identity's or an individual's public key. Now, its purpose here is the certificate authority, also the CA, has validated and issued that certificate, the date range during which that certificate is valid, and also the algorithm used to create that signature. The second one here is the certificate store. Now, this resides on a local computer and stores issued certificates and private keys. The third one is the public key infrastructure. It is a trusted third party that issues those public key infrastructure certificates to entities and individuals after verifying their identity. It signs these certificates by using its private key. And then finally, the fourth one here is the certificate database. And this stores all the certificates approved by that certificate of authority. Here we can see how the elements of the public key infrastructure interoperate with each other. Now, once again, the first step here is the PKI issues that PKI certificate. What we're going to have here is Bob, user down here. Bob initially requests a certificate from that certificate authority. So he's going to make a request to the certificate authority. The certificate of authority authenticates Bob and stores Bob's PKI certificate in that database. So now they store that in the database. The next step here is to exchange that PKI certificate. So Bob communicates with Alice. So we communicate with Alice here using his PKI certificate. Third step here is we verify our PKI certificate. Alice communicates with the certificate authority using the certificate authority's public key. Now, the certificate authority refers to the certificate database, so then it refers back into its database here to validate Bob's PKI public key infrastructure certificate. I hope you're liking this episode on authorities and the PKI Trust System. If you have the time, please leave a comment and let me know what you think about the authorities and the PKI Trust System. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. Certificate of authorities, especially those that are outsourced, issue certificates based on classes which determine how trusted a certificate is. We have a table here that provides the description of these classes. Now, the class number is determined by how rigorous the procedure was that verified the identity of the holder when the certificate was issued. The higher the class number, the more trusted the certificate. So over here, looking at our table, we go from 0 to 5. The higher the number, the more trusted. And so down here, after 5, we have more trusted. As you can see, looking at this, at the scale, the different classes here, this is used for testing, where no checks have been performed. You're testing out your website just to make sure that it handles HTTPS, the SSL certificate. Fine, that's what you're doing for. All the way down to class 5 here. Private organizations or government security. You have to go through sometimes a fairly lengthy process to prove you're actually the organization requesting the certificate. We don't want individuals requesting certificates pretending to be different companies or other individuals. And so that's why we have this rigorous process down here for a class 4 or class 5 certificate. PKIs can form different topologies of trust. The simplest is a single root PKI topology. Here we have the diagram, and it's shown that we have a single certificate of authority. And so right here is our single certificate of authority. It issues all the certificates to the end users, which are usually within the same organization. So once again, you can think of this as a single organization at this point in time. A lot of times this could be your Active Directory server with maybe certificate services on that. Or you could set up a different type of certificate server, but it is the root certificate authority, and you only have one in your organization. Now, the benefit to this approach is simplicity. However, it's difficult to scale to a large environment because it requires a strictly centralized administration, which creates a single point of failure. On larger networks, public key infrastructure's certificate of authorities may be linked using two basic architectures. One is the cross-certified certificate of authority, and the other is the hierarchical certificate of authority. Interoperability between the public key infrastructure and its supporting services, something like LDAP, Lightweight Data Access Protocol, and the X.500 directories, is a concern because many certificate of authority vendors have proposed and implemented proprietary solutions instead of waiting for a standard to develop. To address this interoperability concern, the IETF published the Internet X509 Public Key Infrastructure Certificate Policy and Certification Practices Framework. And this goes back to RFC 2527. The X509 version 3 standard defines the format of a digital certificate. What we're going to do now is walk through an example how this all works together. The first step here is to start with your SSL on a web server. Secure web servers use the X509 version 3 for website authentication in the SSL and TLS protocols, while web browsers use the X509 version 3 to implement HTTPS client certificates. SSL is the most widely used certificate-based authentication. Then we have IPsec down here. IPsec VPNs use X509 when certificates can be used as a public key distribution mechanism for Internet Key Exchange, or IKE, RSA-based authentication. Next, we have the multi-purpose internet mail extensions and the secure version of that. User mail agents that support mail protection with the secure multi-purpose internet mail exchange extensions, SMIME. These protocols use the X509 certificate. Then finally, we have our Extensible Authentication Protocol with Transport Layer Security, also known as EAP TLS. Cisco switches can use certificates to authenticate end devices that connect to LAN ports using 802.1x between the adjacent devices. The authentication can be proxied to a central ACS via the Extensible Authentication Protocol with TLS. All systems that leverage the public key infrastructure must have the Certificate of Authority's public key, which is called the self-signed certificate. Now, the public key from the Certificate of Authority verifies all certificates issued by that Certificate of Authority and is vital for the proper operation of the public key infrastructure. For many systems, such as web browsers, the distribution of certificates is handled automatically. So they hand out those certificates automatically for websites that use SSL HTTPS. Now, the certificate enrollment process is used when a host system to enroll with the public key infrastructure. To do so, the Certificates of Authority certificates are retrieved in band, so they're retrieved as part of the network conversation over our network, and the authentication is done out of band using a telephone. So they get the certificates over the network, but then the authentication is done out of band, like using a telephone network. Authentication no longer requires a Certificate of Authority server. Each user exchanges certificates containing public keys. Certificates must sometimes be revoked. Two of the most common methods of revocation are the Certificate Revocation List, typically known as the CRL, and the other one is the Online Certificate Status Protocol, or OCSP. It was my pleasure to provide you with this wonderful episode on authorities and the PKI Trust System. If you like this episode and you got value out of it, and of course, depending upon what platform you're using, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All of my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. In the upper right is my playlist for my series on network security for the CCNA. In the bottom right is one of my favorite videos that I linked just for you. Thank you so much for watching this episode of my series on network security for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.